Hi everyone, thanks for joining today's Nokia and Intel Core Talk. Today we're going to explore an important development, the integration of Nokia's Cloud Packet Core with Intel Xeon processors, and how this combination is delivering notable improvements in both performance and energy efficiency. I will share some insights about the collaborative relationship between Nokia and Intel. Our work together has achieved some significant results, particularly in how Nokia software has been optimized to work with Intel's processor innovations. This technological partnership is reshaping network infrastructure, and we're seeing real benefits for operators who can now provide enhanced service quality to their users while reducing their environmental impact. Throughout this session, we'll walk through these developments and explain how they're making a meaningful difference in the telecommunications landscape. I am Mike Hawley, Head of Packet Core Engineering for CMM at Nokia, and I will be your host today. I'm thrilled to have Steve Dinkins, Director of Wireless Core Infrastructure from Intel, and we will be discussing the role that Intel Xeon processors play in driving the performance and energy efficiency of the Nokia Cloud Packet Core. Steve, Nokia and Intel have been together on many occasions. We were together at MWC in 24 and 25. We've partnered in webinars, co-authored syndicated articles, and now Intel joins Nokia for the core user group. In most discussions with customers, we hear a strong desire for solutions that push the boundaries of performance advancements, but do so without expanding footprint and power consumption. Can you share some insights on what the market can expect with these next generation telco solutions and how Intel is addressing this market?
Sure. So first, Mike, thanks for having me here. Really appreciate it. Great to work with all the Nokia teams and collaborate with our joint customers. But I'm going to touch on one of the points you made in your question about solutions, right? Because it's very relevant to how we view the market. There are numerous reasons for selecting a new platform, whether there's need for capacity expansion, there could be aging infrastructure that's costing an arm and a leg for maintenance costs. Simply it could be a desire to reduce infrastructure costs and footprint, right? Whatever the case may be, it's obvious the first thing customers are going to look at is performance, right? It's always been king. I do not see that being kicked off the throne anytime soon. However, there are other factors that are at play, right? Other vectors to consider that go hand in hand with choosing the best overall platform and solution for a telco network. Okay, so we know networks are not deployed one CPU at a time. They're not even typically deployed one server at a time, right? The end result for an infrastructure decision is deploying a rack of servers, possibly multiple racks depending on the site, usually even multiple sites. What we look at is really like a tops-down view, okay? So we know the space constraints, so reducing the number of servers needed in that space is paramount. We also know the power constraints, right? So how do we fit the most possible servers in that space, but within the rack power budget? And of course, we know the capacity requirements, right? So having enough compute to address that is absolutely non-negotiable. So we are really at this inflection point that's been building for several years where the best 5G core solution is one that maximizes performance, but it minimizes power and footprint. Okay, so performance per watt, power efficiency, however you want to define it, it's a guiding light as we transform the networks. Mike, so what are the key market expectations for energy efficiency in the telecom industry? Really specifically, I'm looking to see how Nokia is addressing these expectations with Cloud Packet Core.
Yeah. Well, energy efficiency has become very important given the rising cost of electricity and the worldwide focus on sustainability. At Nokia, we've been working closely with Intel to make our networks more energy efficient, and one big opportunity is related to non-busy hour traffic. Our customers dimension their networks to handle the busy hour, the daily hour with the highest traffic, but there are many more hours in the day where the traffic is lower. In the middle of the night, the traffic can be just 10 to 20% of the busy hour traffic peak. And that's where we see a big opportunity. We've developed some interesting solutions like our Kepler component in the Nokia Cloud platform, which keeps an eye on power consumption at the application level. Intel has also brought in their infrastructure power manager that can adjust CPU settings on the fly. When we tested these in our labs, we saw some pretty significant results. We're talking about a 40% reduction in power use at the CPU level and around 25 to 30% at the server level. We're also using newer chip generations that naturally use less power. For instance, Intel's new Xeon 6 CPU is about 60 to 70% more power efficient than its predecessor. We've integrated some advanced features too, like P-state and C-state controls, which help manage power usage more efficiently, and we're using AI to predict network patterns and adjust our systems accordingly. All of this is helping us deliver what our communication service providers are asking for, a more energy efficient 5G core that helps reduce both costs and carbon footprint. It's not just about performance anymore, it's about being smart with how we use our resources. Now, Steve, as I mentioned, we're taking advantage of some of the Intel innovations aimed at improving power efficiency. Could you elaborate on what's being developed and how it impacts the CSP's network?
Yeah, so there's a lot being done, right? I really look at it as three pillars, right? It all starts from the manufacturing side. It's hard to get too excited about these groundbreaking products if the environmental impact to create them is large, right? So we took a goal of using 100% renewable energy in our Xeon manufacturing, and we've hit that, right? In major countries, we've hit 100% and we're above 90% in the rest. So manufacturing is on a great track. The second pillar is we must design our products to be inherently sustainable, okay? It's really an objective from customers to reduce energy consumption. And we don't just make creative tweaks after the fact when a product comes out, right? It's a foundation of designing this into our product years in advance, okay? Xeon 6 E-cores, which Mike mentioned, it's a perfect testament to this approach, okay? It's a focused effort in the design process to create a CPU that fundamentally operates at a more linear and more predictable power curve across the entire load line. It uses less power than a traditional x86 product. So what this means is that in a typical operating range, in a typical operating environment, Xeon 6 with E-cores is going to consume up to 65% less power than similar products. This makes a massive difference in how you provision your systems, what type of servers can be used, and of course, what type of cooling is needed. The third pillar, which really has been long ignored, is what do we do when you push the power button and the servers are operational? Okay, yes, the products that we're creating inherently run less hot, they consume less power, but what can we do about matching the power consumed with the actual load on the system? Okay, as Mike mentioned before, we discovered that there's this massive opportunity. The servers are rarely, if ever, running at 100%, so it gives us an opportunity to be able to reduce frequencies on the platform to match the actual demand on the system. The caveat here is that we are dealing with telco networks, right? These are critical workloads. We can't just set some policy, cross our fingers, and hope that it all works, right? We have to do this intelligently and safely. So this is why using Infrastructure Power Manager, we're able to scale this in real time, and we validate it with real telco workloads. Nokia is validating it with their real telco networks, telco workloads, excuse me. So Nokia has just been an unbelievable partner in this. They are going to be the first to market with Infrastructure Power Manager in what I hope is the 25.7 release. So really excited to see that to come to fruition with the 5G core market. So switch to you, Mike. We're seeing an increasing capacity demands, right? So I've been wondering about your compute infrastructure strategy. With the compute landscape changing, what does this mean for your telco applications?
Yeah, we're witnessing a significant shift in the chipset industry towards higher density compute solutions with CPUs packing more cores than ever before. And in my experience with telco applications, we've traditionally spread our workloads across many low density servers, which works well for smaller deployments. But as we move toward higher capacity requirements, we're finding that our traditional approach of using all these low density servers isn't the most cost, energy, and footprint efficient solution anymore. I mean, so think about it. Today we might need 10 to 12 low density servers to run a high capacity packet core control plane, and we carefully manage the anti-affinity rules to maintain system resilience. But with these new high density servers, we can consolidate this down to just 4 or 5 servers. This brings some challenges for us that we have to address, particularly around the K value in our N plus K resiliency model and the way we handle anti-affinity rules. But we're seeing this clear evolution from servers with 20 cores, like in Cascade Lake, to 32 in Ice Lake, and now 144 with Sierra Forest. And this transition isn't just about having more cores, it's about adapting our applications to make the most of these denser computing environments while maintaining performance and the reliability that telco applications require. And I've seen how this shift can significantly improve our resource utilization and application scalability. Now, Steve, I'd love to get your thoughts on this increase in density of the next generation CPUs, as well as how that impacts performance and power efficiency in the telco network.
Yeah, so Mike, it's no secret that the density of cores in CPUs has just taken this dramatic leap in recent years, right? We played in this 20 to 32 core range for a long time, and now we're finding ourselves at 144 cores. Then we go to 288, and then we may double beyond that, right? So I appreciate that it has taken some work, as you stated, to understand how to scale existing architecture to these solutions. But as you do this work, and as we work close with you, I think there's a couple things becoming very clear, right? The first is like the servers required to provide a certain capacity, whether it's your UPF application with CMG, whether it's your CMM application, the number of subscribers, which of course you're very close to, right? The number of servers can be dramatically decreased, okay? But there's really a spin on this. It becomes very difficult to take advantage of these denser, more performant solutions if the power envelope to achieve this is also dramatically increased, right? We spent the last 5 minutes talking about power consumption and how it impacts customers. If we double the core count, but we also double the power, what have we really done, right? So this is why we're so excited about Xeon 6 with E-cores and how it fits into the telco solutions, right? You start dimensioning for performance and power, you can put these extremely high capacity servers in a small footprint because the power consumption is so low. And we actually showed something with you at Mobile World Congress just a few months ago, where we took a CMM application that was addressing 5 million subscribers, and we put it on previous generation servers, and we put it on Xeon 6 servers, and we were able to reduce the power consumption by 60%, right? So same exact footprint, same subscribers, reduce the power consumption by 60%. So this is what matters, the solution matters, and I think we've really done a great job together to address this and demonstrate it. All right, Mike, so looking back at 2024 and then the first half of 2025 this year, what were some of the key achievements of the Nokia Cloud Packet Core in terms of performance and energy efficiency, and really like your perspective for 2025 and beyond?
Sure. In 2024, the Nokia Cloud Packet Core achieved pretty remarkable progress in both performance and energy efficiency. The performance enhancements were driven by advanced chip technology and the optimized software, and we could get increased capacity to handle traffic. We reduced latency for faster processing and generally improved the throughput for enhanced data transfer rates. Simultaneously, we made significant strides in energy efficiency through the implementation of these optimized hardware components and power-conscious software enhancements and the effective utilization of virtualization and cloud-native technologies. These improvements collectively enabled Nokia to deliver a more sustainable and high-performing Cloud Packet Core solution that effectively balanced operational efficiency with environmental responsibility. Now, looking ahead to 2026 and beyond, Nokia is positioning itself for continued technological advancement and market leadership through a comprehensive strategy focused on three areas. One, the company aims to achieve significant performance improvements through the adoption of next-gen chips and innovative software solutions, while simultaneously emphasizing energy efficiency as a core differentiator by reducing carbon footprints and operational costs for CSPs. Additionally, Nokia is committed to developing cutting-edge solutions for 5G and future network technologies, with particular emphasis on network slicing capabilities and the integration of AI and automation to optimize network performance and efficiency, ensuring that we remain at the forefront of telecommunications innovation. Now, Steve, what are your thoughts on the innovations of the past year, and what are your expectations as we roll into 2026?
Yeah, it's been a very busy year. Just this time last year, we launched Xeon 6 with E-cores, and Nokia, of course, has adopted it. We're very, very excited to see CMG and CMM support Xeon 6 in your July release this year. But being able to witness this huge increase in capacity and throughput with this hyper focus on power efficiency, it's just exciting and it's transformative, right? We've made really fantastic progress of getting Xeon 6 adopted, and we are already in production trials with the Intel Infrastructure Power Manager. And I can't announce the customer now, but I really hope soon we can jointly announce the results for that, because we're very excited. So as we finish this year, we'll be seeing one of the most power efficient telco platforms being deployed in the market. And of course, we're just excited to continue advancements, and we get ready for our next generation E-core products with Intel next year. So Mike, we've covered a lot of ground today. It's been great. We've explored market expectations for high performance, energy efficient networks, and how the Nokia Cloud Packet Core powered by Intel Xeon is delivering on those expectations.
Yeah, so Steve, what are your closing words for our core talk?
It's really simple. It's about deep collaboration, especially with Nokia, right? You've been an amazing partner. We have a compelling set of platforms. You have a compelling set of software. We both have compelling set of technical skills. We bring those learnings together. We bring those mind shares together, and the teamwork is just outstanding as we go create really, really exciting products together that address solutions in the telco market.
Well, Steve, I really want to thank you for the long-standing partnership that Intel and the Cloud Packet Core team have had. It's been a great collaboration. And I want to thank you, the audience, for watching this Core Talk, and we will see you next time.